thank you for showing up here today. As Ivana mentioned, I will be talking about maintaining or building maintainable PHP application and managing the complexity for the long term. So, as Ivana mentioned, I'm a senior PHP engineer contractor via Deva. In my free time, I do technical content, creating technical content in terms of articles or short Twitter tips and tricks, and also on LinkedIn. Sometimes I do mentor people, have worked with startups, scale-ups, and huge enterprise distributed systems. Used to be a full-stack developer, turned into a backend software engineer, so I'm mostly focused on the backend these days. And I have worked with PHP and Laravel for most of my career, but then I've experienced Symfony as well, and I've also worked with native PHP, the PHP language itself without a framework or with a custom framework. And in my free time, I love discussing technical ideas and experimenting with them on my personal projects. More information can be found on my website, davorminchorov.com. And thanks to the people at Crowd Science for teaching me a lot of things related to the things that I will talk about today. It's all about the context that, the context matters so much when we are building projects, and that will determine how we are building those projects, because each context has different problems in terms of, let's say, a brand website or a personal website has some kind of problems, while working at a scale-up software or an enterprise software, which they do have different types of problems in terms of scalability and in terms of code scale. So all of these types of contexts end up at the unavoidable business complexity. They get to that part, and the unmaintainable code is unavoidable. So the context that I'll cover today in this talk will be mostly about a startup that is at least 3 years in production and beyond, and also has at least 5 or 10 developers. So that whenever you have a bigger team, there's a lot of more code that is being released into production, so you'll have to work with a lot more code that way. So what is over-engineering and under-engineering? A lot of people do mention over-engineering, so at least how I understand it is it can be either simple, full of abstractions, and it can be changed easily, or new code can be added whenever the product grows over time, or it can be badly written and completely unnecessary, depending on the context. Similar to that goes with the under-engineered code, which is either written quickly and completely unmaintainable for the long run. It requires many changes all over the place, and but it does do the job quickly, and people are very happy. So here's an example which I can't really show you in the screenshot, but here's the code that I have on my screen. This is just a class. I'll talk about it later, but as you can see, there's a lot of code, a lot of classes here, a lot of things happening, right? And on the other hand, we have this kind of code, which is a single controller method with a simple creation of a member in a database, and it returns a response. Both of those examples do the same thing, but in a little bit of a different way. And so what actually determines what's over-engineered or a under-engineered code? It's the context which is written in, and the level of maintainability and the ability to change it easily when the business rules and processes become more complex over time. The first code example written in an enterprise or a scale-up would be very simple to maintain, because you will always have options to add the code very easily, and you don't have to change code all over the place. Compared to the second code example, if it's written in a brand website and a personal website, it would be very perfect for that scenario, because you don't really have that much complexity, or you don't have a big business running there, or a lot of use cases that you have to cover. If these code examples switch their contexts, it will end up the first example being over-engineered, and then the second one will be under-engineered. Meaning that if you write the first example code in the personal website, it may seem like an over-engineering for no reason, and then the second one, it would be very under-engineered code. With this comes the accidental versus the essential complexity. And as business processes and use cases grow over time, the product becomes more complex, and that is called essential complexity, which we can't really avoid it. That's how the business run in nature. Things change, things grow. A lot more features are being added to the product. A lot more team people or people are added to the team. So a lot more code is being produced. And the first code example, for example, it's easy to maintain because you don't have to change things all over the place. You have specific classes which you can just add, and you don't have to really touch everything. You just can create a single, for example, I have here a few event listeners based on the main workflow, and then everything else will stay the same. As I said, you wouldn't need to touch the main code or the main example class, and the business is complex enough to which the use cases may seem like a very simple, which this code will be very simple to be written in because of the context. And very important, this may be very simple for this context. As I said, the second example makes you think that you can add additional code to the controller, making it work based on the feature requirements as they come in. So you have a bunch of other things that you may add to the workflow, and this is actually called accidental complexity. By adding additional code that it doesn't actually seem like a bad idea at the time, but whenever it grows, it may end up looking something like this. The code doesn't really matter that much in this example, but or at least the idea of it is that it covers a lot of validation. It has a lot of request validation, a lot of business logic related to it, and some calculations, some creations, some creation of records to the database, and then sending emails at the end. And then it does have atomic locks added so that the requests do not override each other. And you may think this is just fine, I can work with that kind of code, but after some time you may get demotivated. You may be scared to change it. You may think that you have time to change it, but that really doesn't really happen that much in the real world scenario. and it will be very hard and bug prone. So, framework coupling and decoupling. We usually learn a framework, we work with the framework, we love it, and we focus with everything that the framework offers us, right? But the problem is that the framework dictates us how to work with it based on the tools that we're given. So we're trying to reuse the framework as for things that we need, which we don't really think that it will be a problem later on. But whenever you're using the framework as much as possible and trying to avoid inventing your own code, this is called framework coupling, which means the business code depends on your framework of choice, and it makes it harder to change over time. Okay, so there are a few reasons why this is bad. This means that the framework upgrades will slow down and the code becomes harder to upgrade. When the direct implementations are being used from the framework, the reasons for the risk of breaking the product is higher because of the required changes, which will affect the product all over the place. This means that the testing will take a while. A lot of people will have to work on that. Even it may take months, which means the business would have to spend thousands of dollars. And moving the code out into a different project, if it makes sense, after the team grows over time, will be a lot harder since you have to touch the same code all over again and make changes all over again. Changing the implementations will require many changes as well. For example, I've seen a bunch of situations where people started with, for example, a MySQL database, but then later on they wanted to switch to a single store database, and they had to switch over, like, I don't know, maybe 40 to 50 or maybe 100 queries all over the place, which maybe it took them a few months to do. Instead of focusing on new features of the product, they focused on refactoring the code or switching to database so that they can improve the performance of the product itself. The framework decoupling solves these problems by by the statement coding to an interface, not to an implementation. You can start, one of the benefits is that you can always start writing custom components instead of depending on a single framework component, if the business needs that based on the requirements. Also, the freedom to structure the code however you want based on the business requirements is also another thing that you can do. The framework is just a tool and it can help you, but the point is that the business needs to drive the implementation, not the framework itself. And it also makes it easier to design the code and test the code itself. Few changes will be required during upgrades, because you will not touch the business code, the business related code. You will have to touch only the parts where the framework is being used directly. This kind of thinking may take a while, since, let's say, we're used to think or depend on a framework for 5 or maybe 10 years, so it would be a lot harder to switch to thinking that, or decouple the idea of the, or decouple from the framework itself, or write the code in a proper way. So, thinking data, and what's the difference between thinking in data terms and thinking in business processes? So, developers are usually taught that when they start their careers, that everything needs to start from from the database and how we're supposed to design the data that we store in our application, but they do not show us, or all of those resources are mostly focused on the on the database, but they're not focused on the business that we're trying to help and solve their problem. Which means business processes and the business use cases are usually neglected, and we don't really care that much about them. Maybe we do know how the business works from, let's say, two or three mentions of something, and then, but we don't really plan it in that way. And then whenever we're working on a serious, like a serious business software, we do a lot of things like validating input based on specific business requirements. It may talk to a third-party service, store the data into multiple databases. It may talk to multiple services or applications. Also, business people are forced to learn what the technical terms are. What's a database, what's an update, what's a create, instead of them focusing on things like what they say when they are building the business. So it's very technical, and it's not that easy to work with. Or communicate with the people. So, as I said, developers do focus on the database, and I would say that designing a database with best practices in mind is important, but the business people do not really care that much about it. Same goes with the technologies that we use. Here's an example of how business processes or business people think about when they design or extend the product. So they say things like choose a restaurant, choose the food to order, apply a coupon, pay the order, approve order, take an order to deliver, pick up the order from the restaurant, take order from the customer delivery destination, and then complete the order delivery. Why is this a better idea, so to speak, to think from business processes, from a business processes perspective? It's easier because you have a unique language to talk to business people, and also it helps you with naming files, modules, classes, variables, methods, and properties. You don't have to think about some, or you don't have to be creative to think some generic term that only you or your team understands. Also, it's easier to understand what the business people are saying, and then you can also design the business-related code without any infrastructure concerns in mind, which means you can write the code without using a database. And then we have things like behavior-driven development and domain-driven design may be useful in such cases. It may be harder to switch the mindset and think and work this way, and also it will take a few years to get into this mindset. As I said previously, since we're used to one way, it's a lot harder to switch to another one. And after you learn about this way, then you have this meme here. I have a friend called Dave who learned some things about event sourcing, and now he can't stop thinking about it, and he's also always saying like, you're all wrong to people who write CRUD applications. Anyway, so planning, right? Developers do plan their technical stuff, but they do not sync up with the business and plan that much in front for the feature that they're working. Maybe they're told we need this Excel export or something like that, but it's always in the head of the developer how the developer understands the problem or what needs to be solved. So there are many ways of planning the business processes, and a few of them I've listed here. It's event storming, event modeling, and event storytelling, right? Some of these may be different, but they mostly focus on the events that are happening in the application itself. The idea of these types of planning processes is that they do bring business people, technical people, and even customers of the service to discuss what the business is all about and how it will work. And here's an example of an event storming session. And this session is not really that much important in detail, but this is how it looks like when you actually plan something in front for a ticket reservation system, I believe this is. And as you can see here, I don't know how much you can see of it, but you can see that the events are being represented here, things that are happening in the application. What are the commands that need to happen? So, and then we have the business rules, things like only one ticket can be reserved per seat, and things like that. So you can think about those in front instead of writing the code and then getting back to the business saying, okay, so we need only eight tickets per customer can be reserved, and business rules like that. It's a lot to discuss here, but I can continue with that. So having a plan of what the business use cases and rules are, it makes it easier to map it into code. So you already have the events that you could use in the application. You already have the commands that you have in here. So you can easily map it into the code and how things will work. It also helps out with the modules of the application, or many applications depending on the scenario. You can also figure out the folder structure based on that, if it's a monolith, and then maybe move it out in a different application if that makes sense. Exploring the domain also helps people to understand it in more detail. It's not just like you come up to people and always ask them, what was this rule in here, because I can't really understand the code and things like that. Or maybe the business people wouldn't know what it is. I've had situations where I debugged some code for about, I don't know, a week, and then it was very critical, and at the end it was just a business rule that the business people didn't know that it existed. So it wasn't really a bug that I was investigating. Anyway, exploring the domain will get ideas out of the people's heads. A lot of questions will be answered, and the goal here is not to expect or chase the complexity, but rather let it evolve, and so that you can manage it later on. So imagine if you have all of the use cases on a board where you can get back to it and just view how they worked, and maybe you can expand on them later on. And here's another example of my own personal project, how I determined that I have multiple modules of the application. Maybe it's not viewable for you, but I'll tell you. So I have a newsletter, and then an identity module, and then I have a membership module, and then scheduling and publishing. And based on that, I can do the same thing with the modules in the application itself, where I have all of those 5 modules as folders in my folder structure. And here we go to the code refactoring section, and I'll switch to my browser to my IDE so that I can show you the code, since the examples are not really viewable. I noticed that. So here's what we're gonna refactor from a controller method that only creates like a member and then returns a repository, a member resource, or I would say the response. Okay, so let's go to the code and switch to the member. Member sign up. Okay, so here's, oh no, that's not it. Here it is. So here's the same thing that we saw in the example, but a little bit more different, I would say. What's the difference here? So instead of saving the member into the database directly, we do pass the data from the request via a command. A command is a class that it only takes data. It's a form of a data transfer object, and the reason for that is just to pass data from one layer to another. And if I switch back, commands are usually dispatched into a command pass, which is basically there to split the layers, or help you split the layers between the presentation layer and then the application layer. And then each command is mapped to a command handler. And if we go to the command handler, here's how the handle method looks like. So the handle method, you may be thinking you could have done this in a service class, right? So service classes are very similar to commands and command handlers, or command handlers specifically. But the idea behind command handlers is that they are classes that can be queued up in behind the scenes if the use case is very processing or time heavy, in terms of it requires a lot of time to be processed. And it also can be decorated. You can also do add some extra logging functionality, or even decorate it, maybe switch it from one implementation to another one, or do something else with the same with the same class. Okay, so here we have a few new concepts, maybe for you, or maybe some of them, some of you understand it. First, we have, let me show you the constructor here. So as you can see here, I'm using only interfaces here. All of these are interfaces. I'm not using direct implementations. The idea is that even if I have to switch something up, I can easily do that in a in the future with my own custom implementation if I need to, or maybe if I switch to a different framework for whatever reason, or maybe implement my own custom framework, I can easily do that here. So instead of using, for example, directly the hasher functionality from Laravel, maybe the business decides that we require something different in a specific way, so I can implement that on my own. There's a lot to cover here, so I'll try to cover as much as possible. and if you do have other questions, or if you want to view the code, it's available on GitHub. I'll provide a link. It's open source. First, here we have here's the command that we saw previously. We have it as a parameter here, so we can use it, and we can pass the email address or any of the data that we need. So the email address class here is it's a value object. So value object is basically a object that takes a primitive value and then validates it based on some business rules, I would say, and it returns the value if that's ever needed. And you can also create some custom methods, custom static methods, so that you can pass the value instead of newing up the class itself. This is usually called the factory method pattern, where you new up the object inside of itself, and instead of doing that all over the place. So the point of the value object is just to take care of the business rules and requirements, and validate them in the any specific layer, for example, the domain layer, because we don't know where the data will come from. It may come from a CLI command, so we don't really validate the request there. Maybe we won't. Or maybe it will come from a third-party service, or maybe our own third-party, or a internal parties, an internal application or something like that. So we always have to validate the data that comes to our domain. And here we have the repository, which checks the existence of the email address, and then it throws an exception if it's already taken. And here's another thing that we have. All these ID, first name, last name, and password are also value objects, which also they do have their own type of validation, so that all of the values will be validated before they're passed to the entity, so that we always know that they're valid. So and we'll also have a place to store all of that validation logic, instead of adding that anywhere in the code. The next thing that I would like to show you is the repository, which it looks like this. It's an interface, right? Member repository, and it has all of these classes, right? Or methods, sorry. And the interesting part is that I can implement this method in multiple types of implementations. For example, in here I have the Eloquent member repository, and then I have another one which is related to the array member repository, specifically made for testing. And here in the Eloquent member repository, as you can see, it does the queries, it takes the data. But the interesting part here that I would like to show you is that the return type is a generic object, or a object that can be used across multiple implementations, which is a read model. The read model is a object that only takes care of data that comes from and it actually works as a output data transfer object, which means whenever we have some result from a database, it takes it off and passes off to the application layer, or maybe even the domain layer, if that makes any sense. So the only thing here is that it takes a bunch of parameters, and we have very similar approach to how the class is being created. It can be created from a eloquent model. It has a specific implementation here, and then it can be created from an array. It can be created from anything else, from a file, from a JSON, from anything that we need. And the interesting part is that if I go to, for example, the array member repository, you will notice that the member read model is also returned here. So we are following the Liskov substitution principle. So let's get back to the interesting part. I think. Let me get back to the command itself. So the command, it also does two interesting things. This is an entity, the member entity, and it has a static method signup, which if I go to the signup method, it only news it up. It creates a new instance of it and raises an event. I'll tell you what the idea behind the events is. But the idea is that the member entity is actually a rich domain model where all of the business logic is handled here in this class. So this means that all of the business rules can be added here, and we can always reuse it, and we will always know that the data that will be stored somewhere will always be valid. That's the idea behind it. I have a very similar method here for marking a email or marking a member as verified, and it also raises an event. So what's the idea with the events? The idea with the events is here. We have a raise method which stores the events that are being raised, and then whenever the events are being released, they will be released in an order which the code happened. For example, let's say we have multiple events that happen in a single use case. We only wanna release those events and dispatch them to the so that the event listeners can take care of them, and they can be executed in a specific workflow. Why is that important? For example, let's say that if I released the event right away before I stored the data into the storage, the database or something specific like, let's say, Elasticsearch or anything else, I may send the event or I may send the email or execute any code before I store the data in the database. This is a lot easier to manage the flow of the code. You can actually manage it and know what happens before what, and you have some kind of order instead of doing that right away or doing that in a chaotic order. You have a little bit more control over your code and what executes. And I believe I covered most of it for now. I don't know if I forgot something. Okay, so the status name is just an enum, which has a bunch of pending, active, deactivated, and deleted statuses that can be displayed as a label if we need to. And then I forgot to show you the event. service provider, where the interesting part here, as I mentioned, I don't have to touch the main class or the command handler. I can always add extra functionality here. In this example, I have a send a member activation email. And it just sends an activation email. But let's say that I wanted to add some things like add the member to a newsletter, to a marketing newsletter, to a community newsletter, to add it to some third-party service. I can always add some additional like side effects to the main workflow. So it makes it a lot easier because you don't have to touch much of the code. You can just extend the main workflow. I think that's. I think I covered most of those things that I wanted to cover. Let me see. Okay. Yeah, I think I covered most of them. So the idea with the repositories that I wanted to mention is that, for example, let's say we start with a eloquent implementation, right? And then at some point we have to implement reports, and then we notice that the performance is a problem there. We can switch it up very easily here and implement a new implementation with raw SQL. Or maybe there are situations where some parts of the product may require some additional performance, and we may want to switch specific places of the product to load the data from a different data source like Elasticsearch. So we can easily do that because we can tell which class to use which implementation, or which use case to use which implementation of the repository. Since we have context, we can add specific context to the container. Let me show you the service provider for that. I think it's the member. So, as you can see here, for example, at the moment we're registering a Eloquent member repository to be used everywhere, wherever the member repository is being used. But we can also use specific context we can use different implementations based on the repository that we want in a specific class. So I think that's what I wanted to cover today. Yeah. So yeah, this is the conclusion. What we maybe learned, maybe you learned one thing at least, or maybe you learned a lot of things, I don't know. But thank you for taking the time and listening. Do you have any questions?